The next project we'll be doing is going to help you think like an attacker. We'll be analyzing a few smart contracts that have common vulnerabilities built into them on purpose, understanding how the vulnerability is created and how to avoid them in your own smart contracts. Security is especially important in blockchain. If someone were to exploit your smart contract, they can potentially steal user funds or your own treasury funds. This project may not help you avoid all exploits, but should help you start thinking about ways others can attack your own smart contract. Let's jump in and start understanding security on Solana. In this project, we're going to go through 3 vulnerable programs and find the vulnerabilities and test them out and showcase exactly how these common vulnerabilities happen. So if you just pull down the GitHub repository for Attack the Bank, you will have 3 different smart contract folders, Bank 1, Bank 2, and Bank 3. And you'll find the first Bank 1 under Bank 1, Programs, Bank 1, Source, lib.rs. All right, so this is our first vulnerable smart contract. You can kind of see that we have 2 different instructions. We have a deposit instruction and we have a withdrawal instruction. The deposit instruction has an amount in the context of deposit. It will have a bank. This bank has an authority, a balance, and the bump. The bump is just for like PDA best practices. And then we print out the bank. Then we just deposit into the bank amount and we're good to go. The withdrawal one right here, all it does is it takes it out of the balance, subs the LAN ports, moves it over to your account, which is the authority, and messages the bank, and it returns basically like a 200 OK. So these are the 2 different instructions that we have in the smart contract. Now, this smart contract is vulnerable on purpose. It has some exploit that you can do in it. So we're going to go dig in and try to figure out exactly what that exploit is. So the first part that we want to look at is first the accounts. Are the accounts set up correctly? Do they have correct signer authority? Is there a different program ownership check that is missing? Things like that. So we can see the deposit account struct right here. It has an authority of signer, so that seems pretty good. We have this bank that is initialized only if needed. The payer or the creator of this bank is the authority, and everything else here seems fine. This is all standard. And then we have system program. So this seems pretty good. It's what you would expect from a place where you're creating an account. This withdrawal struct, it has an authority, it has a bank that's mutable, has one authority, meaning that it's a constraint to make sure that this signer is the authority. And then also we have this bank struct that has the authority set up in the pub key in the actual struct with the balance and the bump. So one thing to note real quick is that we have this authority. So this has one is making sure that the authority within the struct of the bank equals the signer. This is a nice little security check, so that's good. There's one thing that we see right away, though, in this very simple smart contract is that it says init if needed. So let's go check if anything happens that, hey, if I initialize the first time and then try to call again to initialize, if something might happen. So moving back to the deposit. So let's go through this line by line, make sure that we understand the logic on both cases. So if the bank is not already created, we can see here, it'll do init if needed, and initialize because it's not created. It'll set all the required fields, and then transfer the LAN ports into the bank. That's great. Now, what if the account is already created? If the account is already created, this does something very interesting if you think about it a little bit. The bank will be set again based off the authority of who set the deposit instruction. So what you can do, or what you can potentially see already, is that whenever you call this deposit, say you're Alice calling a deposit and trying to deposit some money into the bank, this authority will be set, your account will be initialized, authority is set, and you're good to go. However, if you call with that same account, which is already initialized, and say you're Bob, you can set the authority to yourself and then take all the money in the bank. So let's illustrate that exact problem. Let's go over the test. We're going to write a test for this just to showcase exactly how it happens. It's going to be the bank 1 test. We're going to be using the Anchor default test today to showcase exactly how it happens. So first, we need to set up a provider. Next, we have to set up our connection so that we can actually call the smart contract. So this is provider.connection. And then we have to call wallet, or we have to pull out our wallet. And finally, now that we have all these set up, we can actually just set the provider to the provider. Now, this is all going to be just the basic stuff that you do for every test. We'll get into the actual meat of the vulnerability in just a moment. So we have to create our program so that we can actually do work on it. And then we have to create a new authority because we're going to change this authority over from one wallet to another throughout this vulnerability exploit showcase. So let's do anchor.web3.key pair. So we're pulling in a new key pair, and we're gonna transfer an amount. Let's call it 1 million lamports. All right, so let's create the before test and start creating all of the different integration tests. All right. So before our test, we need to do a few things. We need to pull out our transfer amount. So this is just going to be the total matter of lamports per sol. So anchor.web3.lamports.sol. We're going to create the transfer instruction or transfer transaction. web3.transaction.add, and we're going to create a just simple transfer so that we make sure that we're funding the new wallet that we created so it can execute transactions. So this is just using simple Web3 JS stuff. We're transferring from our wallet, not our provider. So this is provider wallet pubkey. There we go. We're transferring to the authority. So this is this new authority, and we're transferring a certain amount. This is just so that everything's set up. So now we need to actually showcase the deposit and the vulnerability. So let's create a new integration test. We're going to call it deposit. All right, so we're calling it deposit right here. And we're going to have to do a few things. We're going to have to first call the deposit instruction. So right here, we're going to call this deposit instruction with first the wallet. Then we have to call it again with our exploiter, our attacker. So let's call those two instructions. So create the transaction with just a simple await program dot methods dot deposit. So we can deposit an amount. We're going to deposit that amount that we set earlier, just so that we can keep track of it very easily. We have to set the accounts. So the account that it expects is that authority because we're setting the account as we pull it in. So let's just pop that out right there. And set our accounts as the authority. So this is the authority key. See, it's expecting authority of the authority public key. And then we just do .transaction to end the transaction creation. Next, we're just going to call send and confirm so that it actually creates the transaction. So we can call a transaction signature equals await anchor.web3.send and confirm transaction. This is just all standard that we've done before in this bootcamp. So we'll be sending a connection, the transaction. The signer is the authority because it must match what was set in the bank according to our smart contract, and our commitment will just be confirmed. I'm going to log this so that we can look at it in the Explorer, and we should be good to go. Now you can see that this VS Code linter is asking a bunch of questions about what are these things. We never actually did the npm install, so let's go ahead and just get that started now. So we have to go into bank 1, and we just npm install everything. We'll also have to do the anchor deploy in just a moment, so we'll do right after this anchor build, anchor deploy. All right, so we've done the install. You can see all those red marks disappeared. You can see that this account does not exist. It's because we don't have the anchor project built just yet. So let's go ahead and build that. So we have to cd into the anchor folder, or the source, is it the source folder? Actually, this is an anchor project already, so we can just do it right here. So anchor build, and it'll take some time to compile. All right, so the program is now built. We can use it to deploy it now. So make sure before you do anything that you have a local test validator running. So you can see here, I have one running on just running Solana test validator. Otherwise, you won't be able to deploy your program. So we're going to just deploy. So anchor deploy. And now it's just going to deploy the program, and then we can run a test on it and make sure that we did everything correctly. So it's good. Now we just run anchor test. We're going to do skip local validator because I already have it. And also skip deploy because we're not going to change this smart contract right now. All right, so you can see right here, let's see, we got one error. It's because account is not a function. So let's go update that real quick. So it's saying, let's see, account is not a function on deposit. We are right here. Oh, it didn't save. That's perfect. So we've already fixed this issue. We just forgot to save. That's fine. All right. So what this is saying right here is that our account that's trying to do the send, it doesn't actually have any LAN ports. This is because, this transaction right up here, we created it, but we never sent it. So let's make sure we send it. That is just going to be the same thing that we did below, of where we're going to do an await anchor send and confirm. So let's just do that up here within our before. So the transaction will be the transfer transaction. This is making sure that we're transferring money to the authority so that we can actually use it in test. And we can see that the missing signature for public key is right here. So this is because the authority was set to our, let's see, this is for the authority. So we added the authority here as the signer, but we never signed it. We never actually signed this transaction. So we have to sign it with the actual authority before we send it. These are all just normal things that you'll run into whenever you're building smart contracts. So make sure that you sign it if you create a new key pair, otherwise it won't work correctly. So let's go ahead and do that. All right, so we have the deposit, we have accounts, transaction, send and confirm transaction. Everything looks right so far. And then we have our transaction signature. So our signature verification failed for this one. So what it's doing is it's expecting my anchor, this is actually my local wallet. So it's expecting that local wallet to be used here. Now, that's okay. We're not actually using it here, so we need to just make sure that it's set up correctly. All right, so we have our transaction here. Yes. Okay, so this right here, we're transferring from our public key and transferring to our other key, our actual key. So we have to use the provider instead of send and confirm. So let's do provider. And we have to take out authority because it's not actually using that. So this will be just using the transfer transaction. This is only to send from our local wallet. And so it's actually just send and confirm. So this is all set up by Anchor. There we go. Now let's run that test and it should pass now. attempt to load a program that does not exist. Okay, so this is just saying I didn't set it up on the program side, so let's do an anchor clean. And then we'll do this again, but this time with deployment. And that should finally work. Okay, so the error that we got is that we couldn't debit account without a prior credit. So let's check all the balances real quick. You might run into this locally. This is just so that we make sure that we run into any errors that we do run into, we are able to reconcile. So let's go ahead and grab the balances of all of our accounts. We're going to do this right here in the before async. That way we can make sure that what accounts do exist, we know what balances they are. So we're going to grab the wallet balance right here. So this is just an await connection get balance wallet pub key. And then we'll also do the new authority balance. All right, so let's run our test and see where the balances are at this point in time. We should expect that this authority balance is going to be 0, and sure enough, it is 0. And we can see here, custom program error is 1004. This is a specific program ID mismatch. So we'll get to that in just a moment. So we can see that our authority balance is 0 here. Let's go afterwards and make sure that we actually got some balance after we confirmed a new transaction for it. And as we can see, the authority balance before and after, it went from 0 to a bunch, basically. This is actually one sol. So we should be good there now. The other thing is that it's just saying that there's something wrong with the specific public key. So let's go make sure they all match. So this is C14 here. This is not C14. This is HAA. We can go check the cargo toml as well, and the anchor toml. So it's HAA there too. So now let's run it. And we can see here, now that we've reconciled both the balance and the program ID, everything has succeeded. So this did the deposit. Now let's actually showcase the exploit. So we've done that deposit. We can do a withdrawal, but we don't really care to. We can showcase that just fine. We know that it's as expected. So now let's create a new authority. So we have that other authority that has money. We already have that. Let's make sure we overwrite the current deposit bank account with this new authority. So we can just call the deposit instruction again. So we'll just create another exploit transaction. We're going to just use the exact same thing as before, but we're going to exploit it with a different authority now. So instead of having the original authority, we're going to exploit it with my wallet right here. I'm going to then send and confirm. So this is going to be the exploit transaction, or exploit signature. And let us go look at that real quick. So let's put that right here, exploit signature. And we have to make sure that it is going to be signed by the wallet instead of the authority. So right here, what we can do to sign it by the wallet instead of the authority, we just have to do wallet.pair. There we go. All right, let's run this. Let's see, exploit transaction. We need to remember to set it there. And let us run this. So you can see I was able to recall that instruction 2 times. And with the second time, I ran it with this exploit signature. So now let's actually showcase that we can access the funds. It didn't fail, which should be concerning. It should have failed, given that I am overriding the current bank authority with my exploiter's public key. Now let's do the withdrawal. To do the withdrawal, we'll just call the withdrawal instruction. So we can call it right here. So const withdrawal instruction equals await program dot methods dot withdraw. We're going to withdraw that. Let's withdraw that same amount. .bn amount. We're going to have the accounts of the authority being not the original authority, but my wallet, because I have now exploited it to where I can pull from the bank account with my wallet. And then we're going to set it as an instruction. All right, so now what we can do is we can actually set it to where it will pull the full amount. One note here is that we originally, in the exploit transaction, we did it with the same amount as well. We can actually do this with a deposit of 0, just to showcase, hey, there's another constraint that we should have checked. You shouldn't really be able to call this instruction with 0, because that could actually potentially cause other issues. All right, so we have the instruction right here for the withdrawal. Now let us create the transaction. There we go. There's our new transaction. This is the withdraw exploit transaction. And now we just need to send and confirm it with the wallet payer. It's the same as previously, so let's just go pull these 2 lines of code. This is going to be the exploit withdrawal. So this is exploit withdrawal signature, and we're going to log it. All right, let's see what happened. All right, so you can see both my exploit signatures completed successfully. If we actually go pull one of those, so let's bring up the explorer.solana.com, and we're going to go set ourselves to our local host, put in this signature right here, and we can see that we pulled the withdrawal. The authority was that CWT, which is myself. I pulled all the money, and I successfully exploited the bank. So that is something to note about anytime that you're using init if needed. You want to make sure that you don't have this right here where you're setting the initialized values even if the account is already created. An easy way to check all this would be to add something like a Boolean right here in the bank of initialized, and then just checking if it's initialized. So if it's initialized here, so like if context.accounts.bank initialized, throw an error. So this is a very easy way that we could have fixed this problem. Another thing is maybe we should have just had an init and have a separate function or a separate instruction so that you can call it completely separate and you don't have to worry about it. These are just general practices to think about whenever you're doing anything within your smart contract with init if needed. And it's a good showcase of an exploit. So let's move on to exploit number 2. So if you go over to our bank 2 example now, you can see this is a very similar smart contract. We have a deposit, we have a withdrawal, we have an update authority, and this is so that, hey, if I want to update the authority, say, to my partner to be able to withdraw from my bank account and deposit to my bank account as well, this is just adding that capability. This is a new feature. And if you go look in the deposit instruction, you can see there is a new chunk of code that checks is initialized to protect from the previous exploit that we showcased. All right, so let's look through this specific instruction and try to figure out how this smart contract is potentially vulnerable to a new exploit. All right, so we're very familiar with this deposit. We have a bank account that is given an extra amount. If it's already initialized, then don't create these base variables, like just get rid of them so that you can't reset the authority key and do a transfer. That seems all well and done. The withdrawal is the exact same as well. to where you're subbing the LAN ports from the bank balance, you're adding it to the authority. Seems fine. And this is the update authority right here, is just going to update the authority on the bank to a new key. So that seems interesting. So first thing when I see this is that I wonder, how do they check the constraints on who is signing this transaction? Because I don't see an authority check to make sure that, hey, the one who signed this authority is the one who owns this, who has the ability to actually do the changing of authority. So let's go look at those account constraints. So this is the deposit one. We can see here that it's still in it if needed, and we have the authority, so all this looks good. This is withdrawal, has one authority, so it's checking an account constraint across the authority within the bank is the signer for withdrawal. That seems fine. And now right here, we can see that on the update authority, the authority is just a system account. It's not a signer. So if it was a signer, it would use the has one constraint within the bank to check across the different authorities within the bank is equal to the authority on the system account. What this means, however, is that I could pass in the account of whoever the actual authority is and not require them to sign the transaction in order to exploit this instruction and withdraw from the bank. The correct way of doing this would actually have been to have signer here instead of system account, so that you can require that this is the signature authority that can update authority on a bank account. But we don't have that. So let's deploy this and actually showcase this exploit. So we're going to move over to the bank 2 example. The first thing that we're going to need to do is we're going to have to do an anchor build, and then we're also going to have to do an anchor deploy so that we have the smart contract built in. One thing that I want to check before we deploy is that the smart contract equals on the program ID across all of the anchor TOML within the actual code, etc., so that we don't run into those mismatch earlier. So let's go check that real quick. So we go to anchor TOML. We can see that it's a B8 address. We go over here to the librs, go to the top. Looks like it's B8. So it looks like it's fine right now. So let's do an anchor build. All right, so the anchor smart contract has correctly built. Now let's go check and make sure all those program IDs are the same. We have B8 here. I'm going to go ahead and close all the bank 1 examples because we don't need those anymore. So B8 is here. We're going to go to the source. B8 is there as well. Looks like everything is correct. Let us actually go grab that bank 1 test, and I'm going to copy and paste it into our bank 2 test. This way we don't have to worry about doing all the setup in bank 2. It's just all the same code. So let's go put it right here. I'm going to call it bank 2. I'm going to remove these extra things that I just imported. So we need all this. The one thing that's different, we definitely don't need bank 2. We need, or bank 1, we need bank 2. So let's go bank 2. You can see all these things are red, so we need to make sure that we do an npm install again. All right, so npm install has finished pulling in all the packages. Now our thing's very happy. So the one thing I wanted to check real quick is that this is a whole new test on our bank 2. Now we said earlier, hey, bank 2 should not be vulnerable to the same exploit that we used in bank 1. So let's run that test and just make sure that it isn't. So we're going to do anchor test. We have to remember to skip the local test validator. And I'm actually going to also skip deploy because we've already deployed the smart contract. All right, so as expected, we ran into a bug. Well, this is not a bug, it's an error. The first one is that it was trying to pull in bank 1. That's fine. That's just because of this guy right here. There we go. So let's run it. All right, perfect. So we ran into an error, and that's exactly what we wanted to do. We wanted to showcase that this is not actually going to correctly compile for or correctly send for this specific vulnerability anymore, because it's not exploitable via this vulnerability. So let us remove some of the code for this exploit and move on to the bank2 exploit with signature. So we can pull all of this code out right here. One thing I noticed is that we didn't log this out afterwards. And so this test should pass. Let us send it and make sure. Okay, so this one looks like, let's see. All right, so we got the same error that we got earlier. Let's just make sure once again that our program ID is the same across. If I remember correctly, it was because the program that was deployed, the ID was different. So let's go grab that ID real quick. Actually, have we even deployed this? I don't think we've deployed this. That's probably what the problem is. Anchor deploy. All right, so we can already see this B8 is not matched to this S7. So let's go update that. So we immediately know that that's going to be the issue that we're going to run into. So that should be updated now. And now let's run it again with our anchor test. All right, so we can see that the authority balance was not updated. Let's see. The authority balance should have been updated with a new amount of LAN ports. So we provided the transfer instruction. This is the authority balance. We didn't set it again. That is fine. So we'll just call it after, and that'll work just fine. We can also see that it had a problem with the program does not exist. So let's go pull that program real quick. I believe we checked the anchor toml, which we checked and verified that it is the S7 one. We need to check and make sure that it is in the bank. There it is. It's not S7 there. So let's go copy and paste it over. The reason why we showcase these errors is so that if you do run into them, you know exactly how to fix them. As we saw, I ran into them, and since I've done it before, we were able to fix it. So let us pull this out and run the test again. All right, so this passed as expected. We can see our transaction signature. We can see our authority balance increased. So let us exploit this smart contract. Moving over to the test for deposit. If you remember correctly, we have to do the update authority to update to our new authority, which is going to be our wallet. Our wallet is going to be the exploiter, and then we have to try withdrawing. What we're going to see is, as mentioned earlier, if we pass in this authority in the update authority, because it's missing its signer check, we will be able to actually pretend that we are the authority. It's kind of faking the authority to exploit the smart contract in a way. All right, so let's go ahead and create this update authority instruction. So we do update authority instruction equals await program dot methods dot, it's going to be the update authority instruction. We're going to do dot accounts, and instead of the authority being the public key of our current authority, we're going to change into a new authority. You can see that we set it up as the authority here when we did the deposit, and we want to update it to a new authority being the wallet. We're going to call this, and it's going to be dot instruction. All right, so we have the authority. Let's see, it's saying something about authority does not exist. Let's see, name new authority. Okay, so let's go pull the over here. It does have it here. So let's see. So the authority right now is the wallet public key, but we don't have the new authority here either. So we need to make sure that we're also passing the new authority, because that one is what it doesn't know what it is. All right. So let's also create the withdrawal instruction. So this is specifically the withdrawal exploit instruction. Because we did the exploit of updating the authority, we should be able to now withdraw. So we'll do equals await program dot methods dot withdraw with our specific new amount. So we're going to grab the full amount that is currently in there. The authority is going to be our wallet instead of the original authority that was the set during the deposit. And then we just pull this as an instruction and we create our transaction. So const transaction equals new anchor.web3.transaction and add both of our different instructions. We're going to call it an exploit transaction just to make sure that we understand which transaction this is. All right, so now let us send and confirm that we were able to exploit this new smart contract. So we'll do const transaction signature equals await anchor.web3.send and confirm transaction, not raw transaction. This is going to have our connection, the exploit transaction. We're going to have the wallet.pair and confirmed. This is the exploit signature. All right, so let's log this so we can go see it after this. All right, so we have the log. If everything is correct, this test should pass. And that should be concerning to you because it ideally should not pass. We should not be able to update the authority on the bank to something new without having a signature of the original authority. So let's run that anchor test. All right, so we can see that it passed. Let's go look at that signature on the Explorer. So we'll pull up that signature right here. And let's look at the accounts. So we can see that it passed in the CWT, which is the wallet, and the wallet was able to grab new SOL. It pulled some SOL from the account, but it did not originally have the signer of that original authority. It just pulled from it. And we can pull from here on the very bottom. We can see that the update authority correctly was able to update from CWT from the generate key pair to CWT, and it was able to subtract 1 million LAN ports from the bank without ever having needed a signature from the original bank owner. So that is the end of our second exploitable smart contract. Let's move on to the third. So let's go open up bank 3. We'll pull up the program. This is going to be bank_3 lib.rs under bank_3. We're going to go navigate to it within our terminal. And I'm going to anchor deploy right now so that we can check all the different program IDs and make sure they match. We have to anchor build anchor deploy. All right, so we can see that the Solana program ID that we have here for bank 3 is 3W9. Let's go make sure we update that everywhere. So let's open the libs.rs. You can see it's already going to be a mismatch just so that we don't run into that error again. Let's go update it in bank 3 over here. There is also another program ID that is kind of going to showcase our exploit in just a moment. We're going to copy and paste those into their respective places as well, just to get a little bit ahead of ourselves. There we go. All right, so we have bank 3. We have everything in this smart contract. We can see that, like before, we have this deposit. it has a bank with the bank account. It's doing the isInitialized check, so to avoid being vulnerable to the issue that we had in the first smart contract. The transfer is the same. We have a withdrawal. We can check there's something new in this withdrawal. It's pulling in a bank account that it doesn't exactly know what it is and is trying to serialize against itself. So that might kind of tell you like, hey, there might be something here. We'll get to that in a moment. We can see that it's checking the authority here to avoid from the earlier problem that we had on the last smart contract. Does the signer seeds and the transfer. And for this one, we removed the update just to not have any worry of like, hey, there's additional work. Let's look at the deposit. So the deposit, we have an authority of a signer, and it, if needed, is there. And we have the vault of the system account. That's all fine. We have the withdrawal. And we can see right here is that the bank is of type account info or of account type unchecked account. So this is very important. And every time you see this, it should raise some flags as someone that is building a smart contract. If your account is an unchecked account, there could be some things that are wrong with it if you don't check all the required variables successfully or the required constraints on it. One of them is like account ownership. Make sure the PDA is generated as expected if it's a PDA, which I believe bank is a PDA. So if it's not generated just like this, that could be a problem. There can be a program ID ownership. So this should just immediately start raising some flags. We have this vault, we're good to go on there. We have the isInitialized on the bank. So this is likely the problem. So let's go check this is for the withdrawal struct. Let's go check the withdrawal function. So we can see here, we're just pulling the bank and we don't actually, we check what's inside of it, but we don't check that it was owned by anybody. We check the authority, great, it's fantastic, but we don't check that it is currently owned by the program of our Bank 3 program. This is known as something that like you can replace an account in another smart contract and pretend that it is the same account. All right, so let's go showcase how you can do that. So we go over to, there's a fake bank smart contract. You can see here, we have this bank just that is the exact same struct, including the name as the Bank 3. So we can go match them up. So there we go, pub struct bank authority vault isInitialized. Exact same structure. Now, what this means and why it's important is that because I have this outlined exactly the same, Anchor won't be able to catch that it is a different account and that it's not owned by the same program if it is an unchecked account. So what we can do here is we can initialize this account with a separate program, a fake bank program, and then use it to masquerade and get an exploit into withdrawal from someone that actually owns an account on the original bank program. So let's showcase that with some TypeScript. I'm going to go over here. We're going to pull some of the code from the last test, just so we don't have to do it all over again. And then we're going to go into the Bank 3 code, and we're going to update that. So go into Bank 3 tests. We're going to push it right here. We can see that there's some the red lines. It's kind of complaining about us. That's because we didn't do an npm install. So let's do that real quick. All right. And then we got to make sure we replace Bank 2 to be Bank 3 in both cases. All right. So this is the old one. We can see that it's not. It doesn't have any update authority, so let's remove all that code real quick. Just get rid of that. All right, now we need to initialize the other program as well. So we have this const program. We need to also initialize the exploit program. So const exploit program as fake bank. So now we have that exploit program, and we'll be able to showcase that we will be exploiting by creating an account with a separate program to masquerade as the bank account within our bank program. So let us do the full creation. So right here, we're doing the wallet funding. That everything within that should stay the same. We have the deposit, and this is where we're actually going to showcase us exploiting the bank. We're going to do some things that we didn't have before. We have a vault. So we're going to make sure we pull in the vault. This is just a PDA, so it's just going to be a fine programming address sync. And if we go look at what those were in bank3.rs, let's go look at that real quick. It's just of vault, of the string vault. So let's do the buffer.from vault. And then make sure we have the program ID. So now we have the vault account. We have the very similar thing for the fake bank. So we're going to get the PDA for the fake bank. It's going to be anchor find program address sync just as before. And it's actually going to be the exact same. Oh no, it's not the exact same. It's going to have the bank, because if you let's go pull up fake bank. There we go. So fake bank has the vault. Where's the vault? Oh no, it has the bank of the seeds bank. So we'll have to go pull it in with buffer from bank and the exploit program ID. All right, so we have the exploit account, we have the exploit vault, or we have the original vault. Now let's create a fake bank account real quick. So we'll do create a transaction. This will be using it with the exploit program. This is going to be exploit program.methods.initialize. We're going to initialize a new vault, a new fake bank account. So we're going to initialize as that vault. Let's see, just make sure that we have it all set up. Yep. So as that vault, and we need to make sure that we have the authority or the fake authority as our wallet, because that's who we're going to use to steal all of the money. This is going to have the accounts of fake authority of our current wallet. So wallet.pubkey. We're going to pull out the transaction. So it's dot transaction. And so this is going to be our fake bank creation, bank transaction. There we go. We're going to make sure we send that to create the bank. So it's just going to be an await anchor.web3.send and confirm transaction with connection, fake bank transaction. It's going to be the wallet.pair and commitment. And it looks like it created another additional parentheses, but everything is otherwise okay. We've created the fake bank. We've created the vault pretending to be the bank account. Now we just have to actually exploit the withdrawal function with that new account. All right, in order to do that, we're going to create a withdrawal transaction with that new fake bank. So we'll create that transaction right here, equals await program.methods.withdraw. We're going to withdraw some amount. Then we're going to have our accounts of the authority. This is going to be the opposite authority, and we're going to pass in the bank as the fake bank. There we go. So you can see we're passing in a different bank account. We're going to do the transaction. This is going to be the exploit transaction, so we make sure that we call it exploit transaction. And then we do the same thing that we're used to doing, where we do send and confirm. So send and confirm transaction. This will be with the exploit transaction with the wallet as pair. And ideally, this exploit should not work, right? So let's run it and see what happens. Anchor test. Skip local validator because we already have it running. And skip deploy. All right, so let's look at what issue it ran into. So there's some safety check fails. This is because I updated the bank 3 to be an unchecked account. Same thing as account info. So you can tell that Anchor does not want you to do this. It's saying, hey, there's going to be an error. Don't be careful. You're running into some bad territory that you might cause some other issues. So you can see already the safety checks are failing, that the struct is unsafe. It does not want you to create this transaction to exploit the bank. It's trying to keep you from doing this. This is a custom, so it's basically keeping you from being able to do this as expected. The way we're going to remove that is just adding the check, just so that we can showcase this exploit. All right, let's try it again. Okay, so we can see that, let's see, it failed because the program ID did not match. Let's make sure all our program IDs match. We've run into this seemingly with every single one. So 3WD, actually, let's do the deploy so that we make sure that we match it with what's actually deployed. All right, so 3 should be 3W9 in all the banks. So this is bank 3, 3W9. Bank 3 should be 3W9. The other one is GGH. This should also be GGH in the fake bank. Let's go pull that. Yep. And then let's see. So attempted to debit account, no prior credit. That's fine. Let's go pull that, make sure that we have it all right. This should be, looks like it failed at the very beginning. So wallet balance, the authority balance, try to transfer from my wallet to the authority. Let us run it again. All right, so we can see that the wallet balance was updated. So something else happened within deposit, so we can just check that and make sure that we don't have an additional key pair that we're pulling in that we didn't expect. Looks like we're using it find here. It didn't actually send any of the console logs. Do we have any console logs? We have one here. So this one's trying to, so it's trying to confirm a transaction of the deposit from the authority depositing amount. Do we have the same enough amount in this authority? Let's see. We have, yeah, we should have enough amount because we checked right up here that it had an amount. So the authority should be the pub key. The transaction should be authority. It might not be enough. So should be able to do this one more time. Let's just do 2 transfer instructions just to make sure. So this one is a system transfer. Let's just pull this and add it again, just to make sure we have enough LAN ports. There we go. Let's run it. All right, so we can see that the transaction signature passed. Oh, we didn't log our exploit signature, so let's go log our exploit as well. So let's do that real quick. So const exploit signature equals await confirm. And let's log that so that we can check what's going on under the hood. There we go. So it looks like that it doesn't like it because of fake bank. Let's go check fake bank real quick. It's because it has an init. If this was an init, if needed, it should be fine. So let's just change it. It's saying that there's a bank already pulled in, and we have to update the cargo to have the init if needed feature. So let's go pull that real quick. Make sure we run it with deploy, otherwise it won't be able to run successfully. All right, so we have the exploit signature right here. And let's go check in the Explorer. Okay, so we can see the transfer was able to complete successfully. We were able to withdraw from the bank. This is all using a fake bank account masquerading as the real bank account. So going over the 3 exploits that we ran through today, the first program was exploitable or vulnerable to an issue with a if needed reinitialization check, so that if you were to initialize again, it would re-update all the authority variables, and then you could use that to exploit and withdraw the function. We fixed that in the second program. And with that program, we had an update authority issue where without being the signer, you could update the authority with the update authority instruction. And that was also a problem. So remember to also check the signer that you have signers set instead of just system accounts if you require that signature to withdraw or execute successfully. And this last one is a more convoluted or more hard to see one. It's very nice to see if you look for unchecked accounts, but if there's like account info or something similar, it's basically an unchecked account. You'll be able to masquerade or pull in an account from another program and pretend to be that account, and then use that to pass authority checks to pull and exploit the funds. So those were the 3 different exploits we went through. There's a ton more out there in the ecosystem. Generally, the way that you should think about this is, how do I think as an attacker to avoid these issues or other security vulnerabilities on my smart contract? We'll go through more of this in the later project for making your project going to production. That'll go into like how to create a multi-sig for your authority, how to properly fuzz your smart contracts, and more. So check out that. But until next time, thank you for going through this project.